one of which is a highly efficient growing technology, geothermal energy. Cool waters from lakes and rivers are not the only source of water in the Great Basin. In some areas just inches from the surface, boiling hot water emerges, providing a source of heating and energy generation. Today, the geothermal energy fields are limited and scattered throughout these regions. A leader in the technology of geothermal energy is a company called Ormat. Ormat uses their patented Ormat energy converters that come in various versions, shapes, and sizes. The Ormat energy converter operation follows the organic Rankine cycle. An organic Rankine cycle is a thermodynamic process where heat is added to a fluid at a constant pressure. The fluid is vaporized, then expanded in a vapor turbine, which drives the generator, producing electricity. The spent vapor flows to a condenser where it is condensed to a liquid and recycled back into the ground. In a conventional steam plant, the fluid is water and steam. In the organic Rankine cycle, an organic fluid is used. As we look around, we can see that water plays an important part in our everyday lives and has become more and more limited in its supply.
Diatomaceous earth is a single-cell algae that lived in some freshwater lake some 9 million years ago. The source of water was cut off to these freshwater lakes. Subsequent tectonic movement, the diatomite was covered by volcanic ash as some of the gray material over some stream gravel, over some erosional material that subsequently covered it and preserved it. When they die, their skeletal remains is highly siliceous, and there's about 1.1 million of these diatoms per square inch. These are microscopic organisms. First thing you do is you drill and you see what is the depth of the overburden to the diatomite, to the ore.
The depth of the overburden can vary from 60 to 180 feet. Here we see three distinct geological periods of the ore that has dried up. As you notice, there is one layer of diatomite. Below that is a thin layer of volcanic ash from a specific event in time, such as an erupting volcano. Beneath the first level of volcanic ash lies another layer of diatomaceous earth, preceded in time by a narrow band of waste material, with another deposit of diatomite under the waste. How much does diatomaceous earth weigh in comparison to other materials?
Gravel weighs approximately 2,400 pounds, something like that. Our material, a yard, would be a third of that. Pick up any of these chunks you think is going to weigh a couple hundred pounds, and you're going to end up finding out this weighs about 25, 30 pounds. This weighs approximately, I would say, about 18 pounds.
Tell me, Mac, when's the best time for mining?
Better to mine in the summertime for solar drying, because it's quite an expensive thing to dry the material. It has to be zero moisture when it goes through the kiln for the processing. So the more air drying they do, the less natural gas they have to use at the plant. It's real critical to emphasize our selectivity.
What's the next part of the process?
Then you sample the diatomite based on the uniformity. You take the sample to our analytical lab, and we try to duplicate the process which you would go through the plant. You classify it, get the contaminants such as dirt, sand out of it. Then the end product is mixed with soda ash, and it's calcined at approximately 1600 degrees to duplicate what the material would do. Then the finished product would again be put through another air separation process.
The specific requirements of the customer dictates the level and variety of processes before the final product is delivered to the client's facility. What happens to the holes in the ground?
As a part of a continuous mining plant, all the holes would be backfilled as we move out, saving topsoil and replanting it with a native grass and resloping all the waste dump area, reclaiming it to make sure we restore it to the original condition there. Its use was found in Germany over 100 years ago. This material is essentially used for filtration material in breweries, edible industries, as an additive to pharmaceutical purposes, paint industries like the abrasive for toothpaste, edible oil, corn syrup, wine, inert chemical. It's used as a filler, in filtration material.
Which brings us to our next valuable resource, gypsum. Gypsum is commonly found where thick and extensive evaporation beds, which are associated with a sedimentary rock, and are generally deposited in lake beds, seawater, and hot springs from volcanic vapors and sulfuric solutions. In veins, it is formed by hydration to near-surface exposure and is often associated with minerals like halite and sulfur. Gypsum is most commonly used in drywall. North America is the largest user of gypsum board, using some 40 billion square feet each year, with the average home using 7 metric tons of gypsum. Let's take a look inside at how U.S. Gypsum, one of the leading manufacturers of drywall and sheetrock, processes its gypsum into a marketable product. The specially treated paper comes in large rolls and is delivered to the manufacturing facility. The rolls of paper, one of which is called face paper, is made from manila hemp. The second, called newsline, or back paper, is made from recycled matter and wood pulp. Here the two types of paper are fed through a pair of rollers. The paper is heated on both edges and is then run through what is called the edge creaser. Here a crease is indented on the outer edge of the paper. Wallboard slurry mixtures are made up of gypsum and various other ingredients that the customer might request. Additives such as fire retardants, moisture control agents, and germicides, just to mention a few of the possible combinations. The slurry mixture is spread evenly along the paper until it reaches the compressor and roller, which compacts the gypsum core to the proper thickness, thereby creating and forming the board. The board, which is inverted at this point, with the back or newsline paper facing up, goes through the forming station, which is further aiding in the creation of the width, depth, and edge type that the customer has requested. The face paper is wrapped snugly around each edge and is sealed to the back paper using an edge tape that holds the form as the slurry mixture begins to dry. The gypsum board then continues along the assembly line, which can range anywhere from 300 to 800 feet or more in length. The next step on the assembly line is to have the barcode and time stamped on the backside of what will become an individual sheet of gypsum board. At this point, the plastic core has set sufficiently for a knife to slice the continuous strip into specific panel sizes, generally ranging from 48 to 54 inches wide and from 8 to 12 feet long. The boards then arrive at the inspection area, where several inspectors can be found monitoring and ensuring the customer's requirements. After completing the knife inspection area, the panels are loaded into the gas-fired ovens, which can be as long as 600 feet or more. The ovens are maintained at a constant temperature for a predetermined amount of time. Each panel is inspected for moisture content, as the humidity and temperatures were carefully controlled in the dryers. As the gypsum board moves through the facility, the panels are inverted by gentle, precise machine action to ensure that the product is not chipped or damaged. The panels come to the end cut saw, which cuts a perfectly straight edge along the end of the board, and then they are paired together and protected by tape that is applied at each end of the sheetrock panels. The paired bundles are then stacked by machine and ready to be loaded onto the distribution floor. The product distribution point is where the boards are either taken for a supplemental coating on the backside or to another warehouse. If your product requires foiling, the boards are gently loaded onto another set of rollers, where they will begin the foiling process. Here, the foil is placed on the backside of the boards as a customer requirement. The type of metal foils that are applied do vary from aluminum to gold, copper, and silver. Here, the forklift driver loads another shipment of sheetrock on its way to a happy customer. When you're driving through your city and you look around and see new construction going on, just remember the inner walls of most of those buildings will be made with wallboard, made from gypsum.